So we are continuing expanding our knowledge of three variable systems, and what we're going to talk about first is some types of solutions. So if we think back to a two variable system, we have three different solutions that we can fall into. One of them is that we have exactly one solution, which means our lines intersect on the graph at one point. We could have no solution, which means the lines do not intersect ever. And we could have infinite solutions when they are the same line and overlap on all of their values. Now, what does that look like for a three variable system? Because we're moving into three dimensions. Well, with a three variable system, we're looking at planes. So if we have one solution, that would mean that our planes are intersecting at exactly one point. No solution would mean our planes don't touch at all. And infinite solutions would mean that they are all on the same plane. So let's talk about what that looks like when we have those equations. If these are my three equations for my system, I'm going to proceed by solving this by hand the way we've been practicing. I'm going to number them 1, 2, and 3. And I'm going to make a plan on which variable I could cancel. And I'm going to go with z because if I use equations 2 and 3, my z's will cancel out without me having to manipulate them. And when I combine those, I get 5x minus y equals negative 12, and there's my equation A. Now I'm going to pick two more equations, and I'm going to cancel my z's again. I'm going to do equations 1 and 2. I need to multiply equation 1 by 3 in order for those z's to cancel out. There's equation 1. I'm not changing equation 2. And when I combine those, I get, oops, this is not one in the same place, equation B. Now between equation A and equation B, I want to proceed and cancel either x or y. It doesn't matter. Let's say I want to cancel my y's. I've got 3y and negative 3y. So if I multiply equation A by 3, then I know that my y's will cancel. And as I'm going through here, I end up with everything canceling out in 0 equals 0, which indicates to me that this is a system with infinite solutions. But remember, what does that really mean? That means that these three equations all define the same plane. So we need to figure out what is that plane. So what we're going to do is we are going to define our three variables, x, y, and z, in terms of just one of them. So you could pick any. I am just going to go with x for this one. So I'm going to let x be x. Now what I need to do is find y in terms of x. That means x is part of the answer. And I'm going to do that by taking either equation A or B and getting y by itself. Doing this with equation A just involves less math. I don't have to divide, but you could also do this with equation B and get the same answer. So what I'm going to do is take equation A and I'm going to solve for y. That just means get y by itself. So if I move the y over and move the 12 over, I'm going to get that y is 5x plus 12. So I have an expression for y that has x in it. So x is x, y is going to be 5x plus 12. And now what I still need to find is z. So what I'm going to do is plug in or substitute this expression for y into equations 1, 2, or 3 and get z by itself. Again, you can do this for any equation. I'm going to go with equation 1, but you could do it with equation 2 or 3 and still get the same answer. So over here, this is equation 1, negative 6x plus 3 times, and this is where I'm substituting for y. And what I'm going to do with this equation is solve for z. That means to get z alone. So I have to distribute the 3 here. So that's 15x plus 36 plus z equals 16. Combining like terms, 9x 36 plus z equals 16. I need to subtract the 9x and subtract the 36. And I get that z is negative 9x minus 20. Again, if you had done that with equation 2 or 3, you would get the same answer. So z is negative 9x minus 20. So this is the relationship between 3 points that are located on my plane. So I can find any of those infinite points on my plane by picking a value for x and finding the y and z that go with it. So we could say, let's say x is 0. Well, if x is 0, then that means y is 5 times 0 is 0 plus 12. Y is 12, and z is negative 20. So this is one of the solutions that exists on my plane. Let's find another one. If x is 1, that means y is 17, z is negative 29. Let's say x is 2. That means y is 22, and z is negative 38. One more for good measure. Let's say x is 4. That means that y is 32, and z is negative 56. So there are infinite solutions because I can pick any value for x and find a y and z that go with it, but it's not just any random solution. There are a set value that define the plane that these 3 equations are overlapping everywhere for. So this is just to kind of expand your knowledge on 3 variable systems. Take another look at that. You can, again, pick any value for x, and you would find the 2 pairs that go with it, and find an infinite number of points on this plane.